Gas fitter exam cram session, video 32. Okay, so we were talking about places we cannot put gas piping. Okay, within a stair enclosure or required exit way. Okay, those spaces, they need to be clear for getting out in case of an emergency, in case of a fire. The last thing you want near fire is more flammables. In a shaft containing standpipe risers. Yeah, we're trying to keep fire protection separate from, well, things that cause fire, correct? Okay, item 3. Within any space housing a fire pump. Okay, if we don't want it near the standpipe risers, we're not going to want it near the fire pump. And the fire pump is going to have its own room, the fire pump room. So, no gas piping in the fire pump room. Gas devices, equipment shall not be installed in such a room. Such space shall not serve as access to a meter room. So, if they've laid out the basement, let's take for example, and to get to the gas meter room, you got to go through the fire pump room. Something's wrong. It's got to be changed around. Can't do that. The meter room has to have its own entrance, and that entrance can't be located in the fire pump room. No gas piping within fire-rated construction. Okay. Fire-rated construction, anything, you can have 1, 2, 3, and that just tells you how many hours. This particular material will last for an hour before it goes up. And then you have a material that would last for 3 hours before it goes up. In public corridors or exit enclosures, okay, except if we have a residential building and we have no floors below grade. In other words, we don't have a basement or a cellar where we could run horizontal mains to pick up risers for the apartments. Then we can run it at the lowest level. Residential buildings, multi-use residential. In other words, residential, but there'd be storefronts at street level. In those two cases, because you don't have anywhere to run your horizontal mains below the first floor or street level, at the lowest level, so we'll call it the lobby, right? With accessible corridor valves, okay, any valves to shut off the horizontal mains you're running, and to the risers, they have to be accessible, so some kind of panel or whatever. Half a PSI max pressure, so we're pretty much only allowed to use this for the stove piping. 10 PSI at 30 minutes test pressure. So remember, we're going to run half a PSI max in any building, barring exceptions, of course. And when we're running half PSI piping, we are going to test at 3 PSI for 30 minutes, except for this portion of piping that we're allowed to run at the lowest level. That section has to be tested at 10 PSI for 30 minutes. The corridor has to be ventilated as per the mechanical code. In this case, making sure that there's some way for a leak to get out. No piping in the return air plenum. We covered that before. No return air plenum, and also no furnace plenum. And this piping is going to have to be welded. So we know that we were supposed to weld in a half PSI system. We're supposed to weld after 4-inch. The largest threaded fitting was 4-inch, so after that we have to weld. In a 5 PSI system, we had to start welding at 4-inch. Anything over 5 PSI, everything had to be welded. And now also, in this particular case, the half PSI system that we're running in the lobby, in the first floor or lowest level, all of that has to be welded. And then once you get away from the first level, you can run threaded again. Okay, page 65. Concealed piping shall not be located in solid partitions or walls unless installed in a ventilated chase or casing. So, if we got a pour, if we're going to run our gas piping through there, we can't just run our gas piping and then just let them pour the walls. We have to have a chase. Within that, the pour goes around the chase, and then within the chase, we run the gas piping. And then notice also, this chase has to be ventilated. Should there be a leak, the gas doesn't build up in the chase, it gets vented out. Concealed piping shall not have unions. Yeah, the only unions, they leak easily with any kind of vibration or just expansion, contraction. That's why we're only allowed the union between the appliance shutoff valve and the actual appliance within 6 feet, exposed, so that we can keep an eye on it. Tubing fittings, no bushings, no compression couplings, no swing joints made by combinations of fittings. And remember, that means that our swing joint, when we take a swing joint off the riser, it's going to have to be outside, exposed, so we can see it. We can't put the swing joint in the wall, and we can't, if we happen to be breaking over with 2 elbows, that's not going to count as our swing joint. The swing joint has to be outside, has to be seen. Okay, underground piping passing through a foundation wall shall be encased in a protective sleeve. That goes for any piping we run. That's just basic plumbing code. Any pipe you're running through a foundation wall has to have a protective sleeve. And the size of the protective sleeve is usually going to be 2 commercial pipe sizes larger than the pipe going through. So let's say we got a 1-inch pipe. So 1 inch, then 1.25 inches, then 1.5 inches. So the 1 inch will go through an 1.5 inch sleeve at least. And then the space between the pipe and the sleeve, the annular space between below grade gas piping and a protective sleeve shall be sealed. Branches shall be taken off a riser with at least a 2 elbow swing, and that is the same also with branches taken off the horizontal main. So if we're taking branches off the main, branches off the riser, 2 elbow swing all the time. Piping in solid floors. So now we're pouring the floor. We're not putting the piping underneath the floor. It's in the actual pour. Shall be laid in channels. Okay, we don't just stick the piping directly. We don't allow the cement to be poured around the pipe. In channels covered to allow access with minimal damage. So it can be a channel, but you have to have access to it. So usually metal plates, Suitably protected from moisture and corrosive substances. So this channel is not going to also serve as, let's say, a convenient floor drain. Or you can install it in Schedule 40 steel or wrought iron pipe conduit. So conduit here is just another name for pipe. And this pipe is going to be at least Schedule 40 steel or wrought iron pipe. So in other words, the same piping we're running for the gas is the same piping the gas will be running in. Tightly sealed ends and joints, both ends extending not less than 2 inches above the floor, and with a vented outlet on at least one end. And from that vented outlet, you're going to pipe it to a safe location outdoors with the vent terminal at least how far above grade? Let me guess, 18 inches. Not under any opening to the building or overhang. That's always funny. You open your window and you get a big whiff of sun. What's that smell? And the vent terminal is going to be installed in such a way to prevent entrance of water or insects. And like we went over, there's usually a mesh in the vent terminal to keep the insects from going in. So this piping that we're running the gas piping through, this conduit, if one end terminates outdoors, the end inside shall be sealed if possible against the same pressure as the pipe and shall be 2 inches above the floor. So we had to use a conduit, in other words pipe, because we had to run pipe in the floor. Now, this conduit we said was going to be Schedule 40, such that the gas pipe is going to run through it. So the same material that we're running the gas line in. Both ends are going to be sealed. So the annular space, if we have this, the conduit, and then we have the pipe going through it, the space here is going to be sealed on both ends, such that if there should be a leak, it's contained within there. This conduit here shall rise at least 2 inches above the floor. Okay, that's the blanket statement. So if both ends are inside, so for a moment we'll say inside. Okay, but now if both if one end terminates outdoors, which we just did, right? One end terminates outdoors, so we just did that. Sealed, and the end inside shall be sealed, and the seal shall be at least able to withstand the pressure inside the piping. So if we're running a 0.5 psi system max, it should be able to resist a 0.5 psi. The end outside, that's the one where the gas will escape to atmosphere. So the inside gets sealed if we got one inside end, one outside end. But now, what if both ends terminate indoors? If both ends terminate indoors, and we'll just move our wall over, no sealing on either end. Okay, and of course the conduit is still 2 inches above the floor. No sealing on either end. Why? Well, if we do have a leak, we need to know there's a leak, because with the end terminating outdoors, if there's a leak and we seal the end inside, the gas escapes to atmosphere outside. But inside, if we seal both ends, the gas builds up and builds up, and now we have a pocket of gas just waiting for trouble to start. So, if both ends are unsealed, the minute there's a leak, we can smell it, we know it can be addressed. Okay, that's the conduit. I would say, 2 inches above floor is always the case. Remember when we had the unthreaded portion of piping, it has to be at least 1 inch unthreaded portion when it's coming out of the wall, but 2 inches unthreaded portion when it's coming from the floor or patio or deck. Okay, so 2 inches is an important number. They ask that all the time, and you see how it repeats all the time whenever we're dealing with it extending out of the floor. Page 66, this is a question you're going to definitely be asked. This is the one where you got to know solidly in your head. 3.5 inches is the minimum between the bottom of the pipe to whatever surface we're talking about outdoors. So it could be grade, it could be the roof. Okay, and you have to go through all 4 choices to make sure that's exactly what the choice is saying, so you don't get this one wrong. The wording's been throwing off a lot of people. So, page 66, above ground, outdoor, and roof piping shall be elevated at least 3.5 inches above the ground or roof, securely supported to the structure, located where it will be protected from physical damage, and protected against corrosion by coating or wrapping when passing through an outside wall. The main thing, the 3.5 inches. Above ground, outdoor, and roof piping, when encased in a protective pipe sleeve, shall have the annular space between the piping and sleeve sealed, have a vented outlet on at least one end, pipe to a safe location outdoors with the vent terminal, once again, at least 18 inches above grade, not under any opening to the building or overhang, and installed to prevent entrance of water or insects. So this is when we have outdoor piping, and in this case, if we're talking about the sleeve, the conduit, both ends are terminating outdoors. We can interpret that statement as such. One end has to be vented. Okay, both ends shall be sealed, because if it's outdoors, you don't want the rain filling it up, but one end has to be vented, and that vent 18 inches above grade. Metallic pipe exposed to corrosive actions, such as from soil conditions or moisture, shall be suitably protected, so coating, wrapping. Galvanizing, zinc coating, shall not be considered suitable protection for underground piping, although it is considered suitable protection for outdoor above ground piping. So when the meter set is outside the building or the house, that piping you can use galvanized. Underground, no. When dissimilar metals are joined underground, an insulating fitting shall be used. Yes, if we're going steel to copper, for example, dissimilar metals react with each other, accelerates corrosion, so you have to use insulating coupling or a dielectric union or a dresser coupling, an insulated dresser coupling. Same thing as the dresser coupling you see in the meter room, except now there's plastic sleeves to prevent contact between the two metals. Piping shall not be laid in cinders. Okay, you have a burnt out building, you can, they'll actually grind that down, the ashes and the cinders, and use that for fill. Trouble is, cinders, when mixed with water, will create acid. That acid eats right through the pipe. So I would say it's carbolic acid. Let's see. Uncoated, threaded, or socket welded joints shall not be used in soil or wherever internal external crevice corrosion occurs. So, uncoated. We know that when we were going to lay piping in the ground, we had to coat and wrap it, protect it in some way from corrosion. So, the threads are especially vulnerable to rusting, and socket welded joints. We talked about the butt joint, where you chamfer both ends of the pipe, put them together, run your beads, but you could also have, just like copper, you're soldering copper, except now we're talking steel. You have a socket fitting, the steel pipe goes in, and you run your fillet well around where the fitting and the pipe meet. Okay, that is also vulnerable to rusting, corrosion. So you cannot use that as is. You have to somehow coat and protect that before you put it into the ground. So crevice corrosion, that refers to the threads itself, the little crevices, or in a socket weld right at that joint, the crevice between the pipe and the fitting. Approved protective coatings and wrappings shall be factory applied, except, so when we're talking about coated wrapped piping, we actually have to special order that. It's going to be our steel piping, but we can't just take steel that we've been running in the basement and the risers and put that underground and then coat it. We have to have piping that comes from the factory already coated. Of course, when you're installing this, you're going to have to remove the coating to make your connections. So what do you do then? During installation, and according to manufacturer's instructions, coatings and wrappings may be reapplied in the field where damage has occurred during shipping, or maybe a rock fell on it, who knows, or where removal was necessary at a joint. To join this piping, you're using dresser couplings again. You got to remove the coating to get them together. You're going to recoat that before backfill. Underground piping shall be buried at least 2 feet below grade, 24 inches, except that as long as it's not under a driveway, we can get away with 18 inches. Trenches shall be graded such that pipe has a firm, continuous bearing at the bottom of the trench. So we don't overdig the trench and then set the pipe on blocks and backfill. No, we dig the trench such that when we lay the pipe, it lays its entire length on the trench. You can make little bell holes or handholds for where you got to work on the fittings, but it's got to lay on the bottom of the trench. And that, once again, that's just general plumbing code, all piping, all back, when we're putting underground piping, you can't use blocks, all has to lay its entire length on the trench floor. Page 67, piping installed underground beneath buildings is prohibited. Okay, we can put piping underground outside. Here they're saying inside, no, you can't put it underground. Except, there's always an except, if we encase it in a conduit of wrought iron or steel strong enough to withstand the superimposed loads and, most likely Schedule 40, the conduit extends into an occupiable portion of the building. At the point of termination within the building, the annular space between the conduit and gas pipe is sealed to prevent the entrance of any gas leakage. The conduit is designed for the same pressure as the pipe. For any end terminating outside the building, the conduit shall extend not less than 4 inches from the outside of the building and be vented. The vent terminal shall, and once again, no need to keep repeating, 18 inches above grade is the most important thing. The conduit shall be suitably protected from corrosion. Okay, so once again, we're running the piping in the conduit. The conduit extends into an occupiable portion of the building. So this conduit, it cannot be in a crawl space. It's got to be someplace where work can be done. People do their thing. It's you have to be able to. They want to know that somehow something's wrong with it. Someone will be able to see it. Someone will know. Let's see. Yes, that ceiling, same pressure. Okay, so the only other important number here, for any end terminating outside of the building, the conduit shall extend not less than 4 inches from the outside of the building and be vented. Let's see, extend not less than 4 inches. Okay, so no more specifics except that wherever this conduit is coming out, 4 inches from the outside of the building. Gas outlets that do not connect to appliances or a future laboratory shall be capped tight, except for listed labeled flush-mounted type quick disconnect devices, and gas convenience outlets shall be installed as per manufacturer's instructions. Okay, so if you ran a gas outlet, but you didn't hook up to an appliance, and that's it, you're going to leave it that way, for whatever length of time, that's the end of the job there. It's got to be capped tight to prevent anyone from accidentally opening that outlet and gas is leaked. Of course, when we're dealing with, let's say, a chem lab in a high school, and you have your chem tables and you have your row of nozzles where the kids are going to hook up the hoses from the Bunsen burners, and then they turn the gas on. That would be a little inconvenient that every time the kids want to hook up their Bunsen burner, the guy's got to come upstairs and undo every single cap. So in that case, and because they're listed labeled items, and because it's for a matter of convenience, they do not need to be capped, but you have to observe all precautions, including the ones with the manufacturer's instructions. The unthreaded portion of piping outlets shall extend at least 1 inch beyond walls and ceilings, 2 inches above the floors, outdoor patios, and slabs. The outlet pipe or fitting shall be securely supported, not placed behind doors, located in the same room as the appliance. So, yes, securely supported. So, This outlet here, when you're going to reach for it and you're putting any kind of pressure on it or any force on it, it shouldn't be swinging inside the wall out and out. You know, it should be secured so that you always have your at least your 1 inch and you work on it. Shouldn't be moving in and out. Not placed behind doors. Yeah, you're trying to avoid damage. Located in the same room as the appliance. That we knew because any appliance, you know, its outlet, which we consider is the shut-off valve, is always in the same room as the appliance and no farther than 6 feet. What are the exceptions? Once again, listed, labeled, flush mounted type, quick disconnect devices, and gas convenience outlets shall be installed as per manufacturer's instructions. Page 68. Except for approved gas filter, gas fittings, or devices, nothing shall be placed inside a pipe or fitting that will reduce the cross-sectional area or obstruct the free flow. In other words, induce a pressure drop of gas. So, unless, you know, let's say we're talking about what might be inside a gas pipe or a device, a strainer to prevent dirt from reaching delicate components of the device. That is part of the device. That's installed at the factory. So it's already calibrated. It's already been allowed for. You yourself, when you're installing piping, you can't decide, I'm going to add this or that in such a way that all of a sudden now you restrict the flow or you cause an obstruction or a pressure drop. Any restriction, of course, you lose pressure. You can't do that. It's got to be part of the manufacturer's item that you're installing. Piping shall be tested before concealing or placing into service. Okay, yeah, you're running piping and then you're not paying attention, you're not staying on top of things, and the walls go up. Well, you can't test like that, you know. It's like, well, the walls went up, but the test is holding. No, the walls got to come down before the test is accepted. And of course, you know, they're not going to give you your turn on unless it's tested, and you can only test exposed piping. So you can't backfill, you can't allow the walls to go up until the test passes. Okay, making changes in direction. You're going to use fittings, or you can bend the pipe. Okay, you are allowed to bend pipe as long as you have at least 1 inch crotch for 2 inch fittings and up. Okay. What does that mean? So 1 inch crotch. You can bend pipe, and if you're not careful, you can bend it too sharp and kink it. Or you can bend it and not kink it, but you start restricting it. So let's say 2 inch and up, right? So we bent this pipe, okay? And they're saying they want at least 1 inch of crotch. So the crotch is right here. So you got to have at least 1 inch of that, okay? Any less, and instead of having that same diameter going all the way through the bend, you could have where now, because the bend is so small and tight, you actually decreased the diameter. So instead of, if we take a cross-sectional look, here it's still round. Here, it's almost like an oval.